Hello, my name is Dr Timothy Whitehead and I'm the project lead for distributed manufactured wheelchairs. The project started by taking a wheelchair that we designed for children who played wheelchair rugby. This wheelchair was designed to be 3D printed in a distributed manufacturing way. That meant that the CAD model could be sent around the world and people could print out a wheelchair to meet their needs in their specific region. The advantage of this is that we don't need to rely on supply chains, that if we need replacement parts, they can be produced locally on site and that the chairs can be repaired. The idea of this chair was it be made of plastic and that we could use recycled plastic waste to build the wheelchairs in the first place. This project took the wheelchair project much further. What we looked at is we looked at how we can minimise the material use by using topology optimisation. We ran a number of topology optimised simulations using different plastics and metals and lots of different variables. And we took this data and created an optimal topology for a rugby wheelchair for children. In addition to this, we ran 3 wheelchair rugby workshops where we took our wheelchair design, we ran focus groups, we got user feedback, and we implemented all of this back into the overall design. At the heart of this project, we were looking at creating a distributed manufacturing system, and that's what we've done. We've taken this wheelchair as a really nice case study about how we can apply a distributed manufacturing approach to low-income countries. We've created the CAD geometry and the data which can be printed out around the world, reducing the need for international supply chains. This means that if our chair is broken, we can print new components and new parts, and we can fix that locally, thus reducing cost, our reliance on international supply chains, and a more environmentally friendly solution.